Friends, very good morning to everyone. Today, let us discuss Michael addition. This is essentially an addition reaction, as the name indicates, and it is given by Michael. He is Michael. His full name is Sir Arthur Michael. He is an American organic chemist and is known for its Michael reaction. He was a member of National Academy of Sciences and he gave this addition reaction. Hence, it is named after him. What is this Michael addition? Is the subject of discussion for today's class. It is essentially an organic reaction in which an activated methylene group adds to the conjugated olefin to give a corresponding addition product. This reaction occurs in the presence of a base. Later on, it is worked up with acid to get the product. What is this activated methylene group? This is a methylene group which is bonded to an electron withdrawing group. Means a methylene group which is active in nature. When a methylene group is bonded with electron withdrawing group, it gets activated. How is it? We will look into it. Electron withdrawing group which is attached to this methylene group, it stabilizes the methylene. When the deprotonation of the methylene occurs in the presence of a base. Deprotonation, it gives an enolate and this enolate adds up to the conjugated olefin and it undergo 1,4 addition. This is the characteristic features of this Michael addition. In this, a methylene group is conjugated with electron withdrawing group is called as Michael donor. Diethyl malonate is an example for a Michael donor, an activated methylene group. And alpha beta unsaturated ketone like ethyl cinnamate can act as a Michael acceptor. In the presence of a base, comparably a stronger base like sodium ethoxide, it undergo addition reaction. Alpha beta unsaturated ketone like ethyl cinnamate, a conjugated olefin, acts as a Michael acceptor. Here, Michael acceptor has unsaturation at alpha and beta position to the carbonyl group. This carbonyl group can be an electron withdrawing group. When a Michael acceptor, that is alpha beta unsaturated ketone or ester or aldehyde or anything, reacts with Michael donor and activated methylene group in the presence of a strong base, it adds up to give 1,4 addition product that we call it as Michael adduct. The electron withdrawing group here mentioned may be an ester or a ketone or an aldehyde or an amide or a nitrile or a nitro group. Let us look into the mechanism of the reaction. The methylene group is acidic enough to lose the proton as this methylene group is flanked between two electron withdrawing groups, that is the carbonyl group. This carbonyl and that carbonyl pulls the electrons from the carbon, rendering this electron deficient. Thus, with less number of electrons, it is withholding this hydrogen. That's why it is acidic enough to lose the proton. And a sodium alkoxide, like here sodium ethoxide, if I take, it is strong enough to abstract the proton. Is strong enough to abstract the proton and is acidic enough to leave the proton, and that's why proton gets abstracted. And this proton, when it gets abstracted, the excess electrons which remains on the carbon gives rise to carbon ion, and this is shared with the adjacent carbonyl group to give an enolate. This enolate which is formed reacts with alpha beta unsaturated compound. The pi electrons between the carbon and the oxygen moves towards oxygen owing to its electronegativity, creating the positive center on the carbon. And to satisfy the positivity on the carbon, the pi electrons which are adjacent to it moves, creating a positive center over here. This is electron deficient center, and oxygen over here is electron rich. That's why it is unstable. To maintain its stability, the pi electrons moves and forms a bond between the carbon and oxygen, and carbon has to maintain its tetravalency. That's why pi electrons are donated to this positive center, and thus it gets added up. Then the O minus, which is here, it combines with the carbon. The pi electrons moves onto the carbon. Carbon ion which is formed, these electrons are shared with H plus, and it gives rise to an addition product. 1, 2, 3, 4. It is attached at one position, that's why it is called as 1, 4 addition product. This is all about Michael addition. Michael addition has its own applications. This Michael addition has been used in preparation of various types of natural products and drug products. And this reaction is green reaction because it is a very simple reaction and highly efficient reaction. And since the beginning of the 21st century, due to the awareness of environmental protection, more interest has been gained towards green chemistry, where we use it to give the products or the drug molecules without affecting our environment. Due to its greenness, this Michael addition has an important role to play in this century. Let us look into the other reactions in the coming class. Till then, have a nice day. Thank you.